Assalamu alaikum. I'm Shapni Siddiqui from Group 3. The rest members from this group are Jawad, Nusrat, and Samdani. Our project is Environmental Monitor. Here is presentation outline, summary, introduction, design, implementation, analysis and evaluation, and reference. Environmental monitor refers to the tools and techniques that measures air quality of its surroundings, temperature, and humidity in a regular interval. In this process, it sends collected data to a central server through GSM. The batteries are powered through solar. It is suitable for outdoor uses. Here we can see the final implementation. Environmental monitor is developed to observe an environment, characterize its quantity, and establish environmental parameters in order to accurately quantify an activity's impact on an environment. To live in a healthy environment, it is necessary for monitoring abnormality in humidity and temperature. This is a picture of conventional air quality monitoring system. Here is the component list. Arduino Uno has been used as microcontroller. We have used it because it is available, less power consuming, and has enough pin to implement the circuit. MQ135 gas sensor and DHT11 temperature and humidity sensor have been used. Since these are trustworthy sensors, we have used 3.7 volt lithium-ion batteries which are rechargeable from solar power, and boost converter to rise up the voltage. Also use solar panel, solar charger module, regulators, and connecting wires. This is our modular schematic of circuit diagram. From the conceptual diagram of our design, we can see that two batteries are powered by a single solar panel and two separate charging modules. One module supplies to a single battery, feeding into the boost converter to drive Arduino Uno continuously. Another dual battery drives the high power GSM module sensor using relays. The batteries are charged in parallel but discharged in series, so output voltage is doubled and current is continuously supplied. Series outputs from the batteries go through a voltage regulator to safeguard the modules. Arduino controls the GSM module. Data is sent in every 6 hours to the module into a Thingspeak IoT server.
Assalamu alaikum, this is Jawad, role 003. Here is the PCB layout of our designed Arduino Uno shield. It sits on top of our Arduino Uno with desired components and connections. Here is a small demonstration video for our project. Here we can see the sensor is taking input from the environment, and then the GSM module is turned on while the sensors are being turned off, and the GSM module uses TCP protocol to send data to Thingspeak IoT cloud server via GPRS. Here we can see the data sending has been started. It takes around 40 seconds to upload data into the server, while the GSM module performs a lot of steps. In a while, we'll be able to see this data being uploaded. Yes, the data has been uploaded, and as soon as the data is uploaded, the GSM module is shut down and the Arduino is still working. Here we can see the data are correctly uploaded to the server. This is our hardware implementation, and this is the top view. We have collected all the things in a wooden box, and here are the different modules: our batteries, relay, the solar panel, the sensor board, and the Arduino Uno with the PCB custom shield. And this is the GPRS module. This is our designed PCB shield, and this is another PCB we have designed to interface and compile the sensors. This link directs us to the GitHub address of our project, and our YouTube link will be posted after the submission. Thank you. Now, my teammate Suba will explain the rest.
Assalamu alaikum everyone. I will be talking about the topic analysis and evaluation. The first topic is novelty. We have implemented the system in such a way that it is self-sustainable. We have designed dual power sources for power requirements of different parts. Our design keeps the high power components to sleep when they are not required. GSM module is hard to work with, so we have developed the software part in such a way that the GSM module tries iteratively to send data in case of errors and failures and sends SMS if it fails continuously. Our prototype is packed in a rigid box to ensure safekeeping from heavy damages. However, since our model requires humidity measurements, waterproofing is against our interest, so no measure to waterproof the project was taken. Next topic is project management and cost analysis. Here, the products are mentioned which we required to use construct the project. The units required to construct the project was also mentioned, and the unit prices and total prices are mentioned. The total price of our 1 unit project is 4,776 Dhaka. Practical considerations of the design. The considerations to public health and safety for our project is that our project does not pose any hazard to people. Considerations to environment. Our project uses renewable energy and is environment friendly. Next consideration is to cultural and societal needs. Our project would not face any cultural or societal stigma. Next topic is assessment of the impact of the project. Assessment of societal issues. This project can have positive impact in climate change issues by monitoring toxic gas level, which can aware the people of the society. Assessment of health and safety issues. This project's core target is to maintain a healthy and safe environment through monitoring environmental parameters. Assessment of legal issues. We have not used anything in this project that is not open source, so no legal issue is to be faced. Assessment of cultural issues. A culture of caring for environment must be established since people can view concerned parameter values through our project. The next and last topic is evaluation of the sustainability. Using solar panel as power supply, our project is a sustainable one with multiple gas level reading because this is renewable energy. If we evaluate the project's impact in societal context, then this design does not include any agenda against any social issues. The PCB design and circuit scheme are simple and from open source. If we evaluate the impact of design in environmental context, we see that there are no major electronic waste other than the lithium-ion battery, which will provide good service for approximately 3 years in a row. However, this battery cannot be recycled. My next project partner is Ghulam Ahmed Samdani, who will be talking about the reflection on individual and teamwork.
Thank you, Subha, for giving me the floor. Now we will talk about the reflection of individual and teamwork. So if we take a look into the individual contribution at first, we can see that the GSM module interfacing, it was done by role 3 and role 6, and the solar scheme, it was explored by role 18 and role 29. We first implemented initial solar scheme, which didn't synchronize with our system. Then we tried to revise and find an alternative solution. And at the last and final solar scheme, it worked. The PCB designing, it was done by role 3 and role 18. And the assembling of the final project, it was done by everyone of the group. So the mode of teamwork, we try to divide ourselves into 2 sub-teams at first, one to work with the GSM module interfacing and the other to work with the solar scheme. The discussion, it took place online and via Google Meet. We tried to work offline in BUET library, hall and home when it was needed. And thus the whole workload was shared by everyone in the group. The diversity, you can see that our group, it consists of 2 male and 2 female members, everyone from different region of the country. Among these 4 members, 2 members are hall resident and 2 members are attached. So if we take a look into the logbook of the project, after the initial final project selection, we tried to distribute ourselves into 2 different subgroup with dedicated workload. After gathering the components, we tried to implement our works. By July, the GSM module, it was almost done. And but our initial discussed power scheme, solar scheme, it didn't synchronize with our system. At first, we tried to revise the scheme and apply and implement it in our design, but it didn't work due to the unavailability of some components. At August 18, role 29 was going abroad and role 18 was diagnosed with typhoid, so half of the team were unavailable. At that time, the PCB design, it was done by role 3 and role 6. And finally, in August 26, Role 3 and Role 6, they tried to implement an alternate power scheme which worked, and the other tried to collaborate and contribute in this part. And after all this completion, at August 29, the final assembly, it took place, and everyone tried to contribute in the final assembly. These are the references we worked, we followed throughout the whole project work. This is all from our side. Thank you everyone for hearing us.